Hello again and welcome back. Today we are working on solving one-step inequalities. So yesterday we talked about graphing and getting inequalities from graphs and the difference between them and equations, which is equations have one solution whereas inequalities have infinitely many solutions. Um, so, Solving inequalities is going to be super easy, just like solving equations, except the only difference is the symbol that we use to show the relationship between the two expressions that we're using. So, um, just like equations, we're going to do the inverse operation to get the variable all by itself, just like we did with equations. We want to know not what x is equal to anymore, we want to know what x is either greater than or less than and possibly equal to in our inequality. So just like equations, we want to do the same thing to both sides of the inequality by using the properties of inequalities. And we want to check the solution by plugging in and checking. So plugging in. So just like before, the inverse operation of addition will be subtraction. So just like before, we're going to subtract 6 from both sides. So that's the subtraction property of inequalities, which is the same as the subtraction property of equality. We're just using them in inequalities this time. So we want to include the variable and the inequality symbol in our solution. So to check, we can replace x with any number that is bigger, in this case here, than negative 17. So, excuse me, we will pick values that are easy to check. So 0 is very easy to check. So we know that 0 is greater than negative 17 here. So we're going to use that as our variable to evaluate and see if it works. So we plug in 0 for x, and 0 plus 6 is 6, and 6 ends up being bigger than negative 11, so we know that this thing is true. So we're going to do a few here together. Remember, just like equations, we're doing the opposite. So if we're taking 3.3 away from our variable, we're going to add 3.3 to both sides of our inequality symbol. Just like equations, that goes away, and we get our variable by itself, and less than, and 16.2 plus 3.3 is going to be 19.5. So our solutions here is x is less than 19.5. And once again, we can check if we want to. 0 minus negative 3.3 is negative 3.3, which is indeed less than 16.2. So we know we have a solution set that works. All right, so number 2 here, we're going to do the opposite of taking 11 away from our x. So we're going to add 11 to both sides. And x will be greater than negative 3 plus 11 is 8. So x has to be bigger than 8 for this to work out. And once we get the hang of this, it's just like solving equations. We just have different symbols to represent our solution set. So instead of one solution for an equation, we have many, many solutions, because in number 1's case here, so anything less than 19.5 will work. So 0 will work, 1 will work, 2 will work, 2.5 will work, and you see how we can get many infinite solutions from that. All right, so number 3, the opposite of adding negative 2 is just adding 2. So we're going to add 2 to both sides. So we get z is greater than or equal to negative 8, and that is our solution set. Z is greater than or equal to negative 8. And finally, number 4, so fractions aren't going away. We got to get used to using fractions. So we're going to subtract 3/4. Subtract 3/4. And I'm just going to quick my way through this. So negative 2/4 is the same as negative 1/2, and minus 3/4 is going to equal negative 5/4. So W will be less than or equal to negative 5/4 here. W less than or equal to negative 5/4. Alright, so that's addition and subtraction one-steppers, and then multiplication and division. So we're going to solve just like we would any other inequality. We're going to solve with inverse operations. So there's one difference here. I forget what this blank is, but that's not important. So we just want to get the variable by itself. So the one thing that's different is when we multiply or divide each side of an inequality by a positive number, nothing weird happens. You'll see what weird means when we come to it. So just like before, we would divide by 6, and x is bigger than negative 6. Here's where the important thing to remember comes in. When we multiply or divide each side by a negative number, or this is where our something weird happens. So we must switch the direction of the symbol here. So you'll notice here that when we divide by negative 6 to solve for this, our sign flip-flopped around. So let's see what would happen if we didn't do that. So negative 6x is greater than negative 36. Divide by negative 6, divide by negative 6. If we did this, we get x greater than 6, and let's test it. So we'll pick something bigger than 6. 10 is easy to use. So is negative 60, when we plug it back into our original inequality, greater than negative 36? And it is not. So that is why we must switch our sign around when we do this. So a few examples here. So we have to divide by 1/3, but that's just the same as multiplying by 3. Multiplying by 3, and we get x is less than negative 36. Number 2, we have to divide by negative 2.2, divide by negative 2.2, and we get t, remember we have to switch our sign now, is less than or equal to, and let me pull up my calculator here because I'm not quite sure what that is off the top of my head. Let me find my calculator first. Oh, we got Desmos here. That'll work. Desmos. And we wanted 7.26 divided by negative 2.2. And here we see we get negative 3.3. So t is less than or equal to negative 3.3. The opposite of dividing by negative 2, remember, is multiplying by negative 2. So we're going to do that on both sides. A, remember, we multiplied by a negative to solve here, so our sign must flip. So A is greater than or equal to negative 16/3. And then finally here, we have z divided by negative 4. So the opposite of that is multiplying by negative 4. And we get z, we multiplied by a negative to get to our answer here. So our sign must flip. And negative 4 times negative 4 is 16. So z is less than 16 to make this thing work. So those are our examples. So remember, this is just like solving equations. The only difference is the number of solutions that the equation or inequality will have, whereas equations have one solution like we've been finding, inequalities have infinitely many. So there is a homework and an IXL to get done with this. They are both in Canvas, so make sure that you are working through those. Remember to take your photo of your work and submit the photo into Canvas in the turn-in. And then for the IXL, you just need to type in your SMART score and submit that to me. So if you have any questions, be sure to email me. Remember, if we divide or multiply by a negative number, we have to switch the direction of our symbol. Don't forget that part. It's very important, or else we get stuff like this example we did here, where we get an untrue statement when we want a true statement dealing with this. All right, so if you have any questions, feel free to email me, and I will get back to you as soon as I can. And it is Friday, so I will be posting up something new for us on Monday, so be ready for that, and enjoy your weekend. Bye-bye.